Hello and welcome. It is time once again to try to fix something. And today on the workbench we have another PS5 Blu-ray edition. I think this was the 1015 model. Not 100% sure. We'll check. But I think this is a no power. It's in really good shape though, looks like. We'll find out once we get inside what kind of shape it's in. But outside looks pretty good, pretty clean. No major nicks. How about eject? No. No power whatsoever. Okay, maybe a simple power supply this time. All right, let me get some covers off and we will find out. All right, I got the outer covers off and right away I can tell someone has been in here. We are missing screws, like all the screws. Well, they didn't bother putting any of them back, did they? It is a 1215A, by the way. Not a 1015, it's a 1215. So, later version. So what have they done to it? Let's get on into it. Electrical tape on the Wi-Fi coaxes. Probably not a good thing. A lot of screws missing there. Sure, I'd like to get down to this power. Let's just see if I can get down to this power supply. We'll see if it's still putting out anything. Surely if you're just a supply, they would have swapped it out. All right, well, I finally got the power supply out, and yeah, she's putting out 12 volts. At least with no load on it, it's putting out 12 volts. So, we got something else going on. Some of those screws are missing. So it's kind of hard to tell if somebody's been all the way in under this cover or not. But I think we're going to find out. I have the main board and heatsink combo out. I reconnected the power supply to it just to check to see if we have 12 volts. And yes, we do. So it's not loading the 12 volt supply down. It is there and it is working. So we have something else going on this main board. It's probably time to get it inside of the workbench and see if we can find it. All right, here we are inside the workbench. And let's just get right to it. I'm going to be looking around some of these power supplies. You know, you see these large inductors. I'm thinking we have a shorted, main rail, like a 3.3, maybe even the 5 volt. Something is dead shorted, I'm thinking, because it doesn't do anything. Let me get in maybe continuity mode here. That's what I'm thinking. I mean, to not even beep like that. I'm not real familiar with this latest revision board. I'm looking for the 5 volt rail. Maybe right over here. 5 volt rail does not appear to be shorted. Let's see. The other ones, here's some, I see this IC here that generates a lot of voltages. What is that? Make sure I'm not on ground. I may be on ground. No short. I can't tell if this is ground or not. I don't think so. Don't think both sides of that cap should be grounded. So yeah, I don't remember right off the top of my head what that rail is, but this little IC here, which is going to be a dialogue, I think this is going to be a dialogue chip here. Sometimes it's a Rich Tech. They do the same thing though. They generate, it'll have several DC-DC converters built into it and several just, series low dropout regulators in them. So it does a lot of stuff. Let's see if we can take a look at it under that microscope and see what exactly it is. Still not going to know exactly which rail it is because they're not really labeled. Okay, crank up the old microscope. Yeah, let me get this kind of straightened out. This is it's a Dialog DA9065, but sometimes it's a Rich Tech. So this rail right here coming out is shorted to ground, because this obviously is ground. You can see all this bus, all this ground plane here. I'll say that is ground, and that should not be, but I don't remember what that is. But you know what, now that I think about it, I do have a working, is this a 30? No, this is an EDM 31. I don't have one of these. I have a 30, which is probably not very different. Didn't know there was a 31. I'd heard of a 33. Apparently there's a 31 now. So I'm not sure. We can inject there. Let me zero out this meter, because I'm kind of curious as to how low this is. Okay, I've eliminated my meter resistance. Okay, 0.08, 0.07. Okay. It will not be very hard to make some heat with that low of a short. I'd like to know what that voltage is. Let me get out my EDM 30 board and see if it has the exact same type of arrangement in that location. All right, I have dug out my EDM 30 comparison working board here, and it does look like it has the exact same Dialog chip in the same place. So, you know, exact same copper traces in that same location, so it should be the exact same voltages. I'm going to apply 12 volts to this. Let's just see what that voltage should be, assuming it comes up, you know, when the board's kind of in standby. I don't know that it does, but it may come up momentarily. Okay, I got my bench supply connected over here. I'm set for 12 volts at 650 milliamps. Just want to make sure I don't blow up my own board. Yeah, polarity is right. Let's see what we get. 5 volts. So that's 5 volts. Odd. That's a 5 volt input. And I thought this was a 5 volt rail over here. This is the good board. So, yeah, this is a good board. So what is this over here? That is 5 volts. But I didn't read a short. So is this switched in some ways? That is or is the fuse blown? Ah, I didn't check that. So this regular could be, you know, on the other board. This is my good reference board. This is the 5 volt supply, but there's probably a fuse in line before it hits this over here. And this chip may have gone bad, which I think I do have some of these, or either the Dialog or the Rich Tech's version of it. Okay, so that is the 5 volt input, and I think this is also 5 volts on the other side. Yeah, it goes in at least twice on each side of that chip. So this is okay. So it's the 5 volt input to our Dialog IC. Okay, let's see if I can find the fuse and if we have that chip. All right, we are back looking at our broken board, and I was just looking. So there's that 5 volt generator circuit here, and there's a fuse on the other side of the board. F7001 is good. So it's not that fuse, but we don't read a short on this either, do we? Right? But we do read a short. Man, where was that? This one. But we do read a short right here. Yes. So is there another fuse? Very likely another fuse in the way before we reach this. Yeah, right there. Okay, I see it now. F7003. F7003 is blown. Okay. No good. Well, okay. It appears to be the chip itself then, because we're going to have to take it off and see though, but obviously there's a short going into the chip, not coming out. So let's get this DA9065 out of here and see if our short goes away. I bet it does. All right, our chip has been removed. Has our short been removed? Let's find out. Right here. No, we still have a short there. So it's not the chip. I should not have accused it so quickly. Let's look. Now that the chip's off especially, we know that's a 5-volt line, the fuse is blown, so there's no problem injecting power. I just really thought it was the chip. Shows what I know. Let's look under here. Do any of these capacitors look questionable? Like, let me get this kind of straightened up. You know, this one would be on there, and this one would be on there. Okay, and one over here. Oh, you know what? There's another DC-DC converter over here. It's on that same 5-volt input. This one right here. But all these capacitors, I mean, they don't have any obvious cracks in them. Okay, it's time to inject a little voltage. And let's see what gets hot. See if I can maybe tack a wire right there. Let me get my supply set up. And here I am accusing that innocent Dialog DA9065. About 1 volt. I don't know, 1.5 amps. I'll get my ground over here on the negative 12-volt terminal in. Let me get a wire. We'll just attach it right there. All right. Do we need the the thermal cam for this, or can we just use a little alcohol? Because I think we're going to be confined, I think, to a pretty small area. Of course, there could be something on the back of the board here that I don't see yet. Let's try some alcohol. Get a little on a swab. And let's just see. If I turn it on, 1 volt, 1.5 amps. Yeah, we're immediately and currently limiting. It's only a 0.5 watt dissipation though. Nothing there. Is it that one? It is sure dissipating the alcohol, isn't it? Let me make sure it's in the shot for you there. Well, hard to tell. I may have to up the current. Not really see anything up in there. That coil is getting hot. Just not enough heat. All right. All right. All right, let's go up to 2 amps. $800 milliwatts. I mean, nothing's jumping out at me. I see it evaporating off that coil pretty quick. Okay, tell you what. Let's remove this other IC right here. This other little, it's a small DC converter. Let's just remove that. Power supply is shut off. Our chip is off. I'll let that cool off just a second before I apply power. Of course, I could always apply the multimeter. Nope, still shorted. Still shorted. I wonder what's on the other side of the board. It is probably time to get out the thermal camera. I was thinking it'd be confined to this visible area right here on top of this board, but there is always the back of the board, and we don't know where all else this 5 volts goes. It could go everywhere. Let's flip this board over and let's just see what's on the opposite side. Well, I really just see some capacitors. There's the area. You can see the little brown plain stitching under that IC. But just a few capacitors, that's it. Are these bad capacitors? Now let's just try it. I'm gonna try it. Why not? Get my bench supply hooked back up. Get some alcohol ready. And make sure we don't grab the wrong supply, like I almost did there, the 12-volt one. Just don't do that. We want the 1-volt one. Yep, almost, but I checked twice. And on. No current because I didn't get my ground hooked up. Okay, now we're 1 watt. Of course, this whole area is still pretty warm. That capacitor is kind of dissipating some alcohol, looks like. So it's nothing definite. All right. Thermal camera time. All right, we are looking at the back side of the board, the opposite side from where I took off those ICs. Let's just see if anything's getting hot here. Nothing jumping out. Okay, other side of the board. Ah, there we go. There's something. What is that? That capacitor right there. Does appear to be right there. Okay. All right. So it was one of the ones right beside the IC. Okay. Let's get that thing off. Well, after removing that capacitor, yeah, we're no longer shorted. I'll show you. No longer short. So it does appear our little capacitor right over there, although it looked perfectly healthy, was the issue. So, okay, let me get these ICs reinstalled and maybe I can find something to replace that capacitor with. And I think this thing will be back to life. Yep. Took those ICs off for nothing. I hate that. It happens sometimes, though. All right, well, I have reinstalled that Dialog DA9065, I believe it was, and this other DC-DC converter back here. Nothing wrong with those. Confirmed our short is gone. Replaced this capacitor with one from a donor, and the fuse with a donor, F7003. It was blown, of course. Pulled those off a donor, and this, I think, is about a 22 microfarad capacitor, so a pretty large one. I think we're at the point of seeing how much current this thing draws. I've got my supply hooked up here. We're going to see if it does the normal, 300 milliamp draw and then shut back down. Let's see. Nope. Nope, we did not. Something is wrong. Something's wrong. Let me see what I can figure out what it is. All right, I think I know what the problem is because this has bit me before. I think I've gotten flux up underneath the south bridge and stopped the 32 kilohertz oscillator from running. And I can tell you that will make everything stop. And if I get on this test point, like here, you can see there's nothing happening there. Nothing. And there's another test point for the other side of it. And I'm in 10x mode for higher impedance into this scope. Not running. And that has bit me before, and I think it has bit others. And I think some people don't believe it's a real issue, but okay, let me flush out from under that south bridge with some alcohol, maybe a little heat, and get whatever's under there out from under there. It's on the other side of the board, of course, from here. And I bet you she'll run then. Right now we're just stuck at 9 milliamps. All right, after a good flushing out from under our south bridge there to clear the flux or whatever it is, I think this was flux. Alcohol would have probably dissipated. But anyway, a good flushing out from under it. Got my supply is reconnected. Now how much current do we draw? It's a good start. There we go, up to 300 milliamps. And then come back down. All right, that looked totally normal. I think our board is healthy and ready to go. Let's get it back out there on the chassis, and let's just see if it's fully functional now. And just to show, here's our test point. There's our 32 kilohertz oscillator. Happy as she can be. And here's our little capacitor that gave us so much trouble. Just confirm. Rolling out my leads. Let's just confirm this is our issue. Oh yeah, she shorted. Doesn't look too bad this way. I think you flipped it over this way. Or maybe that's just flux on there. Oh, that corner's cracked, isn't it? Yep, that corner is kind of cracked. Anyway, I might zoom into it. Yeah, doesn't look so good there, does it? Well, that was our problem. Well, here we are back out in the garage. I've got this PS5 mostly reassembled. As you may remember, it is still missing quite a few screws, as you can see. But don't worry, I'll source the screws. Let's just see if it works. Power. Blue light. Oh, there's a disc in the drive. Bonus. Do we have some video, maybe? Come on. Oh, white light? No. No. Okay, we're recovering, though. Yeah, we have a white light. And we have a bonus disc. What do we have? What do we have? Oh, a PS4 game, 2K23. I was hoping for a PS5 game. All right, she has done a system check or storage check, and it looks like she is going to come back up. So yeah, this PS5 was dead because of a tiny little capacitor. That happens a lot. But anyway, I'm going to find some screws for this thing so I can finish putting it all back together, make it all nice and pretty. And if you enjoyed that repair, please give me a thumbs up. And I will see you in the very next one. So long for now.